Does anyone remember? When we wanted to investigate lowered contact rate, what did we do in the model? We created a scenario, and that scenario involved what?
Changing the parameter.
Yeah, exactly. Exactly. So we had a lower contact rate. And rather than dealing with the standard contact rate, we lowered it from 1 to 0.5, for example. You'll notice that when you look at a scenario here in any logic and experiment, the ones that are modified are shown in bold. They're emboldened. You see that? So that's a reflection. This bold is an indication of the reflection that we've changed it from the default value for the scenario. That's very useful to look at because often there's a baseline, that uses the default values for all the parameters. Another good reason to specify a parameter, a default for it. And then if you change it, it'll highlight for you. So lower contact rate, it sort of highlights, okay, we lowered that. And then we also had alternatively a situation where we had a duration of infection. And you'll notice that this is highlighted here because we changed the duration of infection. It's bolded. So we had these two interventions, each modifying one parameter, and then we combined them, just as was noted, we combined them together in a single intervention where we had both changed both those values for the whole population. Do you remember that? Okay, so then my little challenge for you was, okay, that's great. We did that. Does anyone remember what happened when we did that dual intervention? How was that different from the baseline? Does anyone remember? The infection died out. Yeah, so I'm going to run the baseline here, and we're going to see what happened. Okay, now I'm running this, and it's run out 5,000, and we saw these interesting patterns that relate individual stories in terms of, number of in terms of the income versus the number of times that they were infected and so on. But for the baseline, we had this continuous progression of infection. It kind of shot up initially, and then it went down to these levels. And for those of you who have any have exposure in mathematical epidemiology, you'll recognize that this was kind of an outbreak phase, and this is an endemic phase where the bug stays circulating, but at lower levels. And the levels were quite different for the low SES population on the top and the high. Why was that? It reflected the different crowding, right? The low SES was predominantly in more crowded areas, hence they were more vulnerable because they had more people from whom they could get the bug, and they were more given an infective person. If that person's a low SES individual, they can pass it to more people to transmit it on to more. So for both of those reasons, when we looked at the burden, it was significantly higher amongst the low SES than among the high SES. Okay, that's good, and we saw that sort of at an individual level in terms of the number of times they're infected, we had a much higher rates where we had significant amounts of zero tail. This is the baseline. Now, when we simulated the dual, what did we get? How was it different? It died out, right? That was the comment. Did it immediately get snuffed out? No, it didn't. It actually ran on for a fair bit of time, but you notice it finished a lot faster. And that would be an indication that any logics, most of its work is associated with handling defense. And if no one's spreading infection after a certain point, it can go, what is sometimes known in North America as lickety split. It can go very, very quickly. Okay? Do you have that expression? No? I had a colleague from Estonia who I was working with in a software company, and I was the advisor, and they were having problems with their server hosting environment, and she had this guy from Alabama on the phone, actually Kentucky I think he was, and he told her, "Don't worry about this problem, ma'am, we're gonna lick it." I don't know what you're thinking about how you're going to deal with this computer, but that wouldn't have been the first thing I thought about here. No, we're going to lick it. Weird, sometimes strange expressions originate from yonder parts. Okay, so this was with this situation where we had the dual intervention in place, and here we had still a disparity in place, but then what happened? Why is there nothing after this point on this which shows the prevalence among high and low SES? And why do these curves flatten out, these cumulative curves? Yeah, it goes extinct. It goes extinct. The bug goes extinct. Now, I would highlight, if you're dealing with a system dynamics model, an aggregate model of the situation, under what conditions will it truly go extinct? Well, if 0 people have the bug, right? And that's true here too, right? But there's a difference between the two, because here, if just one person has the bug, it's on the verge of extinction. It could very easily go extinct, right? From 1 to 0 extinction. What does it take in an aggregate model? How low can it go? Is 1 the minimum that could be in place for a stock? No, it could be a half. It could be a quarter. It could be 0.25. So you may, in a compartmental model, a system dynamics model at an aggregate level of infection and population, you'll actually rarely see extinction represented because it may be 10 to the minus 20 people infected. The smallest portion of the hair of a person, still consider the infection as circulating in the population. This is a non-trivial issue if you're modeling things such as AMR, antimicrobial resistance. And in fact, you can fool yourselves very easily with AMR models in a system dynamics context that are aggregate system dynamics models because it seems like the bug is sticking around at a practical level, just at very low levels, but the levels are so low as to be epidemiologically completely impossible or completely implausible. So here, we have it go extinct. If it goes from 1 to 0, it actually snuffed out. Now, this model omits immigration, it omits other sources of infection, but the point is that we can capture this extinction events quite readily at a somewhat more epidemiologically plausible level. So the infection is kind of snuffed out after this point. That's great. And you'll notice that these corresponding graphs for both the high SES and low SES population are significantly lower. And here's the gradient that comes. We're dealing with far fewer sets of infection. Do you remember that? Far fewer cases for both high and low SES. Great. So I just challenged you to conduct a dual intervention amongst the low-income population. How would you do that? Good. You have a candidate person, and you test if they're low income, right? And if they are low income, we're going to actually, I did something first. I'm going to go fix this. Okay, yeah, I did something, I was fooling around too glibly with this, evidently. So one point of reminder for the team, for the group here as a whole, if you modify scenarios playing around, try to remember to restore them because it's very easy to omit that. So here we're going to have a dual intervention among SES. The baseline rates are going to be 1 and 10 for the whole population, and then specifically among this group, we're going to have person on whom to intervene. We're going to set their contact rate, and then we're going to set their mean duration of infection, right? Okay, duration of infection in days times equals what? 0.5 times equals 0.5, right? Good. That's great. Okay. So
here, if we're going to affect both, and we do so only on the low intervention group, why is this low intervention? Because the only people to whom this intervention is being applied, this dual intervention, are those who are what? Low income, those who satisfy this criteria. So we're going to try running this out. Okay, and there we go. And what you'll notice here is that we see a dynamics here associated with the infection that's quite non-obvious. So in other words, it's no longer monotonically decreasing. We actually see there's lower rates here, lower counts of cumulative infections amongst those on the left-hand side here, and then higher rates and then down. Can anyone explain why that is? Why is it's no longer just this gradient downwards?
Because we've put a lot of effort into reducing infection.
Exactly. We put a lot of effort here into reducing infection rates and vulnerability among the lowest group. But the infection has evidently persisted at higher levels amongst this group that's next higher up, right? So in other words, our targeting seems to have worked for this group, but it is not sufficient, it's perhaps too tight to help a lot of the folks at more modest incomes, not yet wealthy, but more modest incomes. They have yet a higher burden of infection. So our narrow infection or narrow intervention here has lowered the curve for low SES infection count, but it has done so without bringing the rest of this kind of moderate population along. And you'll notice the high SES population infection counts are not that much lowered from before. We had about 40% with 0, and then we have still a peak in the sort of upper 70s. So what we've seen here is that while successful, it hasn't snuffed it out across the population as a whole. Now, let's suppose in the final sort of little experiment here that we wanted to take the same strategy but broaden it a little bit. We wanted to examine this strategy up to a limit not of 400, but say of 1,500. How would we do that?
Before you do that, Max,
Yeah.
could you have just left the intervention parameters the same and just applied it to that group? What would that have done?
So left.
Instead of having, where
Yeah.
you've got perform interventions for person,
Yeah.
just having those parameters that we had before for the dual intervention,
Yeah.
but just confined it to the
Um,
group.
in other words, instead of doing this, if we had simply said, for example, 0.5, just assigned it to it.
If we put 0.5 in the in those parameters
Uh-huh.
above.
I mean
like
here.
we did before, yeah.
Yeah.
And it didn't have any code in.
And then, okay,
there, but just had it for those.
right. The issue is that these parameters would then be, suppose we had, great question, suppose we have 0.5 here and 5. To whom would that be applied? That's actually to everyone in the whole population.
Oh, so you can't just.
So we can't just put in there, these apply to everyone. These are the default ones, and this adjusts the default ones for this certain subpopulation
Right,
as
so
delineated by
that's
this
that.
criteria.
Okay, right.
Does that make sense?
Yes, thank you.
Okay, sure. So suppose we wanted to take this, though, and examine it among those who are, say, less than $1,500 in income. How do we do that? Yeah, we just changed it to 1,500. You know, it is tempting to just modify it, but that's how you can easily get in trouble. So I just did copy and paste, okay? And what I'm going to say is among low and low medium SES or something like that. And you'll notice that it's copied the requisite things, and all we have to do is change it to this. You notice these things are still indicating bolds, and that's because they're different from the default values for this. It's nothing about it's not different from the one from which we copied it. That's not what the bold indicates. It's different from the default values. So I'm going to say from below 1500. And you run something like that, and now you're going to be potentially bending the larger part of the curve, presumably at larger expense. But what just happened, folks? What just happened? Where is it? What happened? Sorry? What just happened? I just ran this, and it ran lickety-split. What happened? What's going on? What do you see here?
The infection doesn't spread.
The infection just dies out in no time. Okay, let's try this let's try this again. Maybe it has something to do with the random number seed. Maybe it was just a fluke. Right? Okay, let's take this. Let's use a different random number seed. Let's try it again. You know, maybe it was just the luck of the draw. Okay, there we go. Running it out. Okay, this one seems to have persisted for longer, but it still died out. Let's try it again. Okay, this will be a different random number seed this time. Dying out again. It's dying out very reliably. Okay, so this low and medium works pretty well, but how low can we go? Could we restrict this, say, to 1,000? Okay, try restricting up to 1,000. Could we see this phase change if we, target enough? Now, of course, there's a risk of being penny wise, pound foolish. If you do it for a larger group, sure, it costs more up front, but then if it's extinct after that, man, are you going to be saving a lot of resources? So, you don't want to be too penurious, up front in terms of snuffing it out. But you can see that even up to 1,000, wow, it's doing a lot. And we could go lower than that, right? We could put in place and try 750. The point is here, you can get change. And I want to emphasize this point. On whom are we intervening right now? Is it on everyone? No, it's only on people who are low income. But who is benefiting from this? The entire population is benefiting from it. We're intervening on a low income group, and there's ripple through effects of great significance for the whole population, is there not? We are shifting, ladies and gentlemen. We are bending that curve in a most profound fashion for the entire population, to the effect that, for the population as a whole, both high SES and low SES have, across the board, only the small number of cases, right? You could see this fewer than 5 cases. So not only has the low SES been benefited, do you remember when we looked at the very first scenario this morning? The low SES was lower, but the medium one was still high. But now we've pulled everyone with this. We've intervened on a big enough group, a big enough set, that we've actually been able to snuff the infection out for everyone. And that is a systems effect. The whole is greater than the sum of the parts here. Those are not solitudes, the high income population, the low income population. It's not merely we're saving money by investing in the low income population. In fact, ladies and gentlemen, we are targeting the low income population in the lower mid income population in such a heavy way that we are lifting all boats. We're helping everyone across the entire population, and helping both that population directly intervened upon and others. So I thought that was an interesting little result from this model. This capacity to focus on a population subgroup, to see in a profound way the ripple through effects for another group, and to see so directly that that change, when we're overly focused on the narrow group, it affects the narrow group, but it doesn't spread, it isn't shared as forcefully among the whole population. So this issue of targeting, is something which we can pursue with these models because they capture that individual richness. We can target interventions based on the individual's history, based on their position in a network, based on their geographic location, based on the specifics of their characteristics in a way that an aggregate model just wouldn't allow us to focus. Okay? Is that helpful? Okay, great. So we just built on yesterday's example. I'm tardy in sharing these examples, but I'll be posting all these models wherever possible to the Google Drive.